Good morning, good afternoon, good evening, wherever you are based in. Welcome to the third workshop. Sorry, the number over there, but welcome to the third workshop in the Polkadot Hackathon North America edition. For today, we are going to cover an introduction to Ink, and Hernando later on will actually be bringing you through the content that's been prepared. Before we begin, it's just a reminder for those who are joining today's session and have not yet registered for the hackathon. You can scan the QR code, or Sophia will probably drop the link in the chat box for you to register for the hackathon. Essentially, this is the second stop of the global series, which Polkadot has started since last year. And we have lots of things lined up for this hackathon in itself. Quickly bring through the categories for participation. Essentially, we do have 5 main categories which you can submit your projects for. None of them are in sequential, but just going to briefly mention that the 5 categories are interfaces and experiences, DAO and governance, Web3 and tooling, DeFi and NFTs. These are the 5 main buckets that you can select for submissions of the projects. And in this edition itself, we have also included quite a number of ecosystem teams who have actually contributed challenges, of which you can integrate to the main category that you are building for your submission as well. What we are trying to do here is really to explore the endless possibilities that each of you individuals and teams can really come up for in terms of submission. However, you can take on one or more ecosystem teams to be integrated to the main category submission as well. So running through a few that have contributed to challenges. One thing to highlight is that we also have one bounty that is with 4 ecosystem teams coming together: Subquery, Moonbeam, Akala, and Hydra DX as well. So do have a look. Those information are actually on dev post and similarly on the participants guide if you have already registered for the hackathon, which you will receive as well. We have a prize pool of 613,000 so far, and partial of it is funded by the Polkadot Treasury, which will be awarded to the category winners. Essentially, we have overall winner walking away with 30,000 with Hackathon swag box and discount for Substrate Runtime Academy. And each category would be, we will kind of have first, second, and third place. And last but not least, we are empowering all you out there, your friends or families or anyone that you know can actually contribute to vote for your submission. And we are awarding 3 teams for the community choice as well, each team walking away with 5,000. Of course, apart from all the category prizes, there are also prizes of varied sum that will be awarded for each ecosystem teams challenge. If you'd like to find out a little bit more, do reach out to the ecosystem teams challenge on the Hackathon channel, which is on the Polkadot Discord server as well. So today it's introduction to Ink. We do have a networking session that's going to take place later on at night at 8 p.m. PST or 11 p.m. EDT, depending on where you're based in. It's going to take place on Gather Town. Information about the access of the Gather Town can be found on the Hackathon calendar, which you can save as well, both accessible on DevPost, if not the participants guide. Similarly, we do have another workshop that's going to take place on 14th of June. And we still have lots more ecosystem teams workshops that actually started yesterday as well, and mentor office hours along the day. So one thing to highlight is that we are having an in-person hacker house that's going to take place in Brooklyn, New York City from June 23rd to 28th. The event venue is going to take place as Industry City, and right now registrations is now open. We do have limited number of seats, so grab the opportunity now to secure your seat at the Hacker House itself. Thank you, Sophia, for putting the registration link as well. You can either scan the QR code or click on the link to join us. We will get back to all those who have actually registered ahead of time by next week to confirm your attendance. But essentially, this will be a space where we have mentors to help you along with your projects. There are workshops from various ecosystem teams and similarly our Polkadot team as well. And we are going to have lots of fun as well. So join us in person. Myself will be there, and I hope to see you together with the Web3 team as well. Other than that, just quickly running through, basically there's two methods of registration. Either you can actually scan the QR code, which will bring you to the website. But if not, you can actually head down to devpost.com and you can click on Polkadot Hackathon North America Edition and just kind of join the hackathon. Once you have registered, there is three to-do things, which is essentially really important. Number one, to join Polkadot Discord server, there will be a hackathon channel specially created to help you find folks to join your team if you have not formed one. There are mentors who are there to answer any of the questions that you have, be it from Web3 Foundation, Parity Technologies, or all the ecosystem teams. They are all readily available to answer your questions. Do read the Hacker's Guide, which we have comprehensive information of all that you need to know about the hackathon. And last but not least, do save the hackathon calendar so that you don't miss any session as well. This is just a sample of content that you will be getting from the participants guide. There are lots of information that you can find all the way from submissions requirements, judging criteria, who you can find for help, and so on and so forth as well. So please have a look and bookmark it on your browser so that you can access it at any point of time as well. Right, so enough of introduction of the hackathon. I would like to bring Hernando in, where he will bring you through introduction to Inc. Before I pass the time to him, just a reminder, if you have any questions for him during the entire session, you may drop them in the Ask a Question tag as well, and he will get to them along the way as well. Right, so Hernando, the time is yours.
Yeah, thanks, Justin. Well, so I think that GatherTown networking stuff sounds pretty fun. It's a little late for me, but anyways, let me share my screen and let's get this started. All right. Cool. Can everybody see?
Yep.
All right. So yeah, today I'll be giving an introduction to Inc, which is Parity's smart contracting language. I won't go too deep into how to actually write Inc contracts. My goal here is more to tell you guys about, like, give you guys context about, the Polkadot ecosystem, smart contracting, and really just point you to resources so you can, along the hackathon, discover, everything you need to, because there's a lot of stuff to cover. So a little bit about me. My name's Hernando. I'm a core developer at Parity Technologies. I've been here for a couple of years. I initially started actually working on the Parity Ethereum client back in the day. But nowadays I spend all my time working on Inc and kind of like evangelizing it at events like this. I don't work on this alone. So here's the big team of people behind all this as well. We've got a few Rust core developers and also the team that works on the JavaScript tooling and the UI, which I'll show you guys in a bit. All right, so let's get to it. What is Inc? So Inc is a Rust-based domain-specific language used for writing WebAssembly smart contracts. And I know this is a lot to unpack, so let's break it down into a couple different sections. So first, this Rust-based thing. So one of the design goals of Inc is to just be Rust. And if you're familiar with Rust development at all, you'll see that Inc tries to follow that very closely. And at Parity, we are huge fans of Rust. We've been using Rust for years because it's nice to write, it's safe, it's fast. And in the context of smart contracts, it's actually really important to be safe and lightweight. There's a lot of classes of bugs that are impossible to do in Rust that are common to do in something like Solidity. And when you've potentially got millions of dollars of users' money on the line, you need to be sure that your code works. So that's why we use Rust. And I guess to get to the second part, this embedded domain-specific part, it means Rust plus a tiny little bit of code that we've added on top. And I'll show you an example of that in a sec. So the second part, this WebAssembly part, if you're not familiar with WebAssembly, you can kind of think of it as so it's this portable code format, kind of similar to the JVM for Java. So you can get a bunch of languages that compile down to this thing called WebAssembly and run it in all sorts of different contexts. The first use case it was used for was building applications on the web. But we saw a lot of benefits of it and have started using it in the blockchain space. For one, it is very lightweight, very small. It looks very much like the code your computer would run, so it's fast to execute. And it's also deterministic, which is really important when you're running in a blockchain environment. We can also compare it a bit to the EVM. I won't get too deep into that, but we think that WebAssembly is a much better suited format for the stuff we want to do in the future. And yeah, the EVM just, isn't quite there anymore. So this is the hello world of Ink. If you're familiar with Rust at all, you'll see that for the most part, it's just a Rust contract. The only things that are different are these little annotations. So that Ink contract, the Ink constructor, Ink message, all these, like that is Ink. That's all you need to add. And these annotations do some magic behind the scenes to make sure that this code can compile down to WebAssembly and that it's formatted correctly. But again, if you're coming from Rust, it's basically just Rust, and that's the magic of it. Now I want to zoom back a bit and talk about the context or the tech stack in which we're developing these applications on. So, this is part of a Polkadot hackathon. So Polkadot has to, play a role here. And for those that aren't familiar, Polkadot is really a community of blockchains. And not just any blockchains, of application-specific blockchains. Polkadot doesn't exist in isolation, though. There is this, its wild cousin, its canary network, Kusama, which is a pre-production environment for Polkadot. And together we kind of call this ecosystem the .sama ecosystem. So I'll use that term later on, which is why I want to introduce this. And the architecture of Polkadot is like this. So in the center, we've got this thing called the Polkadot relay chain, and it's really the kind of the brains behind this whole operation. Then around it, you can see all these different blockchains. And each one of these blockchains is an application-specific blockchain. It can be hyper-optimized to do one specific thing and do it really, really well. Now you might think, how are we going to build these application-specific blockchains? Isn't building a blockchain from scratch really hard? Yes, it is. But luckily at Parity, we've built this thing called Substrate. And Substrate is a framework for building application-specific blockchains. And Substrate takes care of doing a lot of the heavy lifting for you. So you don't need to think about writing your own networking protocol, or writing your own consensus algorithm, or writing a transaction queue. The only thing you have to focus on as a builder is writing your application's like specific logic. So that's what we call the runtime. And you do this by putting together a bunch of Lego blocks. So you'll build your logic out of these Lego blocks, and we've got some provided for you. So we've got things like contracts and staking and governance. But you are free to go ahead and build your own. And actually, we encourage you to go ahead and build your own. And you'll put all these building blocks together to eventually make the logic of your chain, which we call the runtime. And then a little word about terminology here. These building blocks are called pallets. So that's how I'll be referring to them for the rest of the presentation. In particular, we want to focus today on one of these pallets, which is pallet contracts. And the idea behind this pallet is that it can kind of execute these WebAssembly smart contracts. So if you're looking at the picture, I'm going to work my way up. So we've got this thing. It knows how to interpret WebAssembly, but it also provides a couple other features. So it is able to read and write to the storage of your blockchain. It is able to do things like cryptography. And it is also able to do things like resource metering. So again, we're in a smart contract environment. We have to assume everything is malicious, and we need to make sure, like, the blockchain needs to defend itself from malicious actors. So we need to, meter our resource consumption. So that's what this palette provides. Then if we, look at the top part of the photo, we've got all these different languages. And the main idea here is that all these languages can compile down to WebAssembly, and they can kind of understand this API that Palette Contracts exposes. So again, the API to read and write to storage, do cryptography, resource management, all that. So as long as you can compile down to WebAssembly and you know how to use this API, you can be executed, or you can run on Palette Contracts. And then Palette Contracts is just one of these building blocks in your application-specific blockchain. All right, before I go there, does anybody have any questions at this point about how things get executed? All right, no, so let's keep going. All right, so where does Inc. and I guess smart contracting in general fit into the .sama ecosystem? So we see it as like there's probably three main sort of use cases that you can think about. So the first one is, so in the context of Polkadot, these application-specific blockchains are called parachains. And you can have a parachain that's dedicated for smart contracting. So you can think of it sort of like Ethereum. Ethereum is dedicated to running smart contracts. So you can have a similar style of parachain in the .sama ecosystem. Another one is you have sort of like a bit of a hybrid where you can have a blockchain which exposes certain primitives. So for example, let's consider some sort of DeFi parachain, and it exposes certain things like, functions for swapping tokens, maybe for taking out a loan, just certain primitives. And then it allows application developers to leverage these primitives through smart contracts. So the smart contract isn't necessarily the main star of the show here, but it's just a way to be even more flexible in whatever you're building and give your builders flexibility. And then the third one, you can think of Inc. sort of as a gateway to becoming a parachain in the Polkadot ecosystem. So you might test out your application in a smart contract. It is kind of a low barrier to entry. It's easy to write. And then you test out, are you going to get users? Do people like this idea? If you do get enough users, maybe you can write one of these specific building blocks called palettes. And if that gets enough traction, then maybe you can justify having your own blockchain and all the power and responsibility that comes with it. All right, let's talk about the actual development workflow now. So everything we do is based off Rust. So your first step is going to go and install the Rust compiler and all the associated Rust tooling. Then we're also going to need this tool that we've written in-house called Cargo Contract. And Cargo Contract is basically a thin wrapper around the Rust C compiler. So you use it to compile contracts, and it also generates a bunch of extra information that's useful for application development. So I'm gonna switch over here, and let me know if you guys need the text here to be bigger. I know it can be hard to see stuff on these crowdcasts. Yeah, the links I'll share all the links after. Don't worry about it. Okay, so we have this cargo contract tool, and how we install it after you got all the Rust tooling is through cargo install cargo contract. So that's pretty easy. I don't need to install it because I already have it. The next thing we're going to do is actually go ahead and build generate like a template for our smart contract. So we can do that with cargo nightly contract new, and then we need the name of the folder. So it's going to be Flipper. So we see created Flipper. We can go in here, and you can see that we've got a couple files. Yeah, I hope this is big enough. So we've got the cargo.toml file, which includes all the dependencies. And then we've got this librs file, which is where our contract lives. So let me open that up. We can take a quick peek here. So this is the same contract I showed you guys a few slides ago. But it's got, some comments and a couple other things, but fundamentally, same contract. We can, let me close this. We can go ahead and build it using cargo contract build, increase font. Big enough, bigger. Do one more, just to be safe. All right, so we can build our contract using cargo contract build. We'll give that a go. And this does a couple things. So I said it was a thin wrapper, but it did have some extra logic. So one thing it does is it checks for, it basically links your contract. So basically, if there's any kind of unidiomatic usage of things, or maybe some security vulnerabilities, or that sort of stuff, it'll warn you about it. It's not very clever right now, but we are working on adding more things. Then it builds the actual WebAssembly file. So you see that somewhere here. And then it optimizes it as well. Because we're going to be deploying this stuff on the blockchain. We need it to be optimized for size. Okay, cool. So it generated everything. And you can see that we've got 3 build artifacts. So we've got the contract itself. So we've got the contract bundle, which is the code and metadata. We've got the code itself, and then the metadata. And what is this stuff? Well, let's dig in and see. So we can do this, Flipper, WebAssembly. And we can see that this is just a bunch of gobbledygook. We can't read it, right? It's like the binary WebAssembly. In order to make sense of this, though, we've got this metadata file. And the metadata is, it tells you everything about the contract in a kind of language agnostic way. So again, you've got a bunch of gobbledygook, but you need to know what the actual constructor arguments are. And that's what the metadata tells you. Or what messages can I call from the external world? And this tells you everything. And this metadata bundle is meant to be used by things like UIs. So when we have a contract on chain, it's just this binary blob, but the UI needs to be able to decipher everything in order to correctly generate, the arguments and transactions and fire it off. So you can think of it as the Rosetta Stone, basically. And then we also have this this contract bundle. So we can also open this. We can't read that. Oops. Just want to open this. There. All right, one more time, maybe. Why can't I? All right, here, one sec. Oh, I was vimming it out. That's not what I wanted to do. One sec. There we go. Okay. So this contract bundle contains both the metadata and the code. So it bundles everything together. And as developers, this is actually what we're going to be working with. So you can see this is the WASM blob. Can't read it. And alongside it, we've got the metadata. So this is what we're going to upload to our UIs. Oh, and I guess one last thing I wanted to show you guys before I leave this. I mentioned that everything was just Rust. So if we go to the Flipper again, you can see down here that we've got this test module. This looks like basically Rust unit tests, except for this one annotation. And if we want to run this, we can just do cargo test, and it'll compile our tests and run them. Yeah, cool. So, everything works as you'd expect. So yeah, this just goes through the build steps we did. So cool. Let me just stop here and see if there's any questions before we continue. So I'll start with what is Cargo? What's it built with? So Cargo is it's like the build tooling for Rust. So you can call the Rust compiler directly. You can do like Rust C and then pass in some arguments, but that can be pretty cumbersome. Cargo just kind of wraps that. So you can build your code, you can test it, you can install dependencies, all these sorts of things. Does optimizing while I'm deployed? No, so actually optimizing it improves the runtime performance because you have less instructions to execute, which is better for the user in the end because they end up paying less gas. Then I think the other questions we'll answer later. All right, let's keep going. Okay, so we've built our contract. Now, what do we do with it? So as developers, we want to check that everything works. We're going to call functions and all this. So we've got a couple different options for this. We've got a UI that we've built called the contracts UI, which is what I'm going to be showing you guys today. We also have this thing called the Polkadot.js UI. And this one's it's got like every feature you need, not only for ink development, but for substrate and runtime development in general. Whereas like the contracts UI is geared just for contracts. And then using Cargo Contract, you can actually also deploy and interact with your contract if you want a CLI tool. And this is quite nice because you can like script certain tasks, and it can be good for automation, running as part of your CI or maybe a test suite or something like that. On top of that, we also need some sort of local node. We need to deploy our contract somewhere. And we have this like starter kit basically called the substrate contracts node. And what this does is it includes that like contracts building block in a default substrate node. And it enables a couple other features which make development easier. I'll show you that in a second. So the UI I've got here, that's this contracts UI. Let me put this to the side. And then here I also have the contracts node. So I've cloned it from GitHub. And I can run cargo build to build the binary. I built it before, just so you guys wouldn't have to wait. And then I can do target debug substrate contracts node and run with this -- dev flag. And we can start a local blockchain, which is pretty cool. I guess you should know that if you don't want to build this from scratch, we also do provide binary releases. So you can just download them from GitHub. So that might be easier for you to get up and running. Cool. Let's remove this one. And what we can do is so maybe first let me make this a little bigger. So you can see that it's already got a couple accounts like pre-populated. And this will be useful for development. It means you don't need to go and get testnet tokens or anything like that. And then previously we built our contract and it gave us the location of it, right? Now what we want to do is we want to upload this flipper.contract file to the UI. And what this will do is it'll end up uploading the code to our local node. And then the UI itself will use this metadata part to understand what's going on. So you can then interact with it. So we can see it already like populated the name, which is cool. So before we deploy it, it asks us, hey, how do you want to set the constructor argument? Do you want to set like the salt so you can deploy the same contract multiple times without like re-uploading it? I'm not going to get into that, but it's a cool feature. If anybody wants to talk about after, we can. And then yeah, the storage deposit limit. Same, it's another cool feature of Substrate, but I'm not going to get into that now. But point being, it understands these arguments, and it only does that because of the metadata. Let's go ahead and deploy this. Cool, so looks like it was successfully deployed to our local node. We can see some stuff happening here. Looks good. And let's go back to the Flipper contract for a second, actually. Just take a peek at it. So the Flipper contract exposes two functions. This one called flip, which, so there's, actually maybe I gotta give you more context. So the idea behind the Flipper is that it just stores a Boolean on chain, and the value can either be true or false. Then it provides these two functions, one to change that value of the Boolean stored on chain, and one to read the value of this Boolean. So we can start by reading it, and it's pretty easy. Right now it is false. We weren't required to sign a transaction or pay any fees here because we're not actually modifying the blockchain in any way. We're just reading what's already there. If we want to change this value though, we got to sign a transaction, we got to pay fees, because everybody on the blockchain will need to know about this change. So let's call it, looks like everything succeeded. And then if we read the value, we can see it is true. So everything worked as expected. Now, let's say you want to debug your code. Since it's just Rust, we can do similar things, and we can do some basic debugging, like print line debugging, which is great. So we have to run the contract node with a slightly different set of flags. So let me grab that from here. So we got to run with this error and debug thing, and I'll explain what it is in a second. So what this does is that in the logs, it'll filter out for any log that isn't error, or I guess it'll just show logs that are of the error severity, or logs that are from our contracts building block of the type debug, and then nothing else will show. So we can do that. And then we can actually here do format. And then here we're just going to read the value. I guess we want to keep this somewhere. And then we want to actually print it. So we can do this debug print line thing. And yeah, so again, what we're doing is we're going to read the current value in storage, and then we're going to print it to the console. So nothing too crazy. We need to remember to build this contract again. And then we will get rid of this one. This one's old. Don't want it. And we'll upload the new version. So notice how our node is running. The UI does understand that there's a node running, but there's nothing printed yet. But if we grab stuff from here, you can see that it's printing this value is false, which is good. And then if we change the value, let's call this, and do get again, you can see it's printing this value is true. I think it may have shifted, yeah. But you can see it's like, it's updated. So that's cool. I guess a couple notes on this, like again, if you wanna print stuff from your node, you need to have these logging features enabled. You can only do these debug messages on things that don't modify the state. So I told you how flip modifies state. This print line stuff won't work there, but get doesn't modify state. So you're good to go there. Is there anything else? No. So I'm going to stop here again for questions. How does the UI know it has to use a local testnet? So if we go back to the UI, you can actually change what node it uses. By default, because this is a development UI, it knows to use the certain port for the local node. But we can change it to like a remote network. So this Rococo network is, it's a test network that we've deployed stuff onto. But if you have your own, test network or different test network you want to use, you can change it and use that. Are contracts written separate from pallets? Yeah, so contracts are separate from pallets. As I mentioned, the architecture is contracts, and then those contracts run on top of, a pallet. It doesn't even necessarily need to be our pallet. There are other people building pallets to run smart contracts, but that's the architecture. And then you can integrate, you can have contracts call into the runtime. So let's say you have a pallet for transferring assets. Again, it's not part of the contracts pallet. It is something separate, but it still lives in your runtime. Your smart contract can access this functionality using a feature that we have called chain extensions. And it allows for two-way communication between the runtime and your smart contracts. So yeah, just look at our documentation on chain extensions for that. All right. Anything else? No, the others I think I'll answer later. All right, cool. So in general, your smart contract doesn't live in isolation. It's usually part of a bigger application or, like something user-facing. So I just want to give you guys a little idea about how that works. So first, like all this stuff will assume that you're using the Polkadot.js API, which is, I think, pretty much the only way to interact with smart contracts from like a front end at the moment. So yeah, let's get to it. So the workflow here is you have some set of users, and they're going to be interacting with your unique front end. They're not going to be interacting with this development front end. They're going to be interacting with something you built. Your front end is then going to make a remote request to some RPC node. And that RPC node is going to kind of like talk to the blockchain, basically. So you can see that in our blockchain, we've got a simple contract deployed on there, and that's what we're going to be using for this example. And then the way that smart contracts interact with your application is through these things called events. And events are kind of notifications coming from the blockchain. So you might do something like transfer some funds. The smart contract logic will do that. At the very end, it'll emit a notification telling the outside world, hey, this transfer happened. And then your front end will pick up on that and respond accordingly. We talked about how there's certain operations that change state and don't change state. So you can basically read whatever you want from storage without actually submitting a transaction. And this is kind of like the pseudocode to do that. And then we can also send, I guess, extrinsics, or what are, you know, if you're coming from Ethereum, are called transactions, which are things that do modify state. One thing I want to highlight here is the use of the await keyword. So you got to remember that things happen sort of with a delay or asynchronously in the context of blockchains. You know, this transaction needs to get included in a block. This block needs to get produced and propagated across the network. So you're not getting like instant, you know, feedback from the blockchain. It takes a while for things to happen. And your application logic needs to be built with this in mind. Yeah, so I'm not a JavaScript developer. I can't go too deep into the details here, but you can go read about the documentation. And yeah, I just want to give you guys like an idea of like how your smart contract would fit together in the context of a bigger application. Cool. So now you've got an idea of what's going on. What should you build? So I've got a couple ideas here. I guess in light of all the Terra Luna stuff happening, I think seeing a stable coin built with ink would be pretty cool. You can probably build it in the same style as Terra or Luna, but just don't deploy it to production. I think it would also be cool to see some DeFi primitives built. So automated market makers, liquidity pools, that sort of thing. And there's already like a lot of implementations out there in the wild in Solidity that you could potentially port. Mixers as well. So again, we look at Ethereum, Tornado Cash is out there and live. Maybe somebody could build this with ink. And then this last one is more of like, I don't know, like a code exercise. Like, I don't know if any of you have ever seen the underhanded Solidity contest, but the idea is to write a contract that looks inconspicuous, but actually does something underhanded in the end. I think it'd be cool to see this as well. I don't know if you get any prizes in the hackathon for it, but you'd at least make me happy. Okay, and then where do you go from here? So I think the best starting point is our GitHub repository, so that parity tech/ink, because that's got links to basically everything else. It'll dispatch you in the right place. Another one is ink.substrate.io. So this is just a general documentation portal we have. Actually, I can walk you guys through all this, all these links. Got them open. So yeah, this is the Parity Tech Inc. repo. So you can see it's got tutorials, documentation, developer docs. So here's that documentation portal I mentioned. You can read about why use Rust, how to get started, all the different macros. So those annotations I showed you guys. We can also go to tutorial, and actually we can get there from the front page here as well. This is probably what you guys are going to want to use to start with, because it'll walk you through setting up your Rust environment, like getting everything you need in order to succeed, and walking you through all the basics. We also have the developer documentation. So if you're already familiar with Rust, this page won't look very scary, but it's basically the reference documentation for Ink. There's a lot of good info on here, and you're gonna be referencing this page during development. And then the JavaScript docs as well. So there's a little section on how to interact with smart contracts. Yeah. And then if you want to get in touch with us, there's a couple different ways. So the main one is this Stack Exchange page we have. It's generally for Substrate, but we do have specific tags for contracts and Ink. So if you've got any sort of question, any technical question, go ask there, and we try and answer. We also have this room on Element for general like release announcements and announcements about Ink and smart contracts. So you should also join that. And then that channel is also bridged to Discord if you don't want to use Element for whatever reason. I think the bridge was down last week. I'm not sure if it's back up. So if you join, it doesn't work. Sorry, but let us know and we'll try and fix it. And with that comes the end of my presentation. So I guess I'll see what questions you guys have and see if I can get them answered. All right, so how does TPS degrade when moving from native substrate runtime? So it's definitely going to decrease. So if we think about the architecture of smart contracts, or even yeah, we'll start by that. So you got to remember that the smart contract is running as part of a pallet's logic. Then that pallet itself gets compiled down to WebAssembly and run by Substrate. So there's already some losses there. Smart contracts are also considered to be malicious or adversarial, so we can't trust what they're doing, which means we need to check their resource usage through this thing called gas metering, and that's also expensive and adds time during execution. But what the trade-off here is that you end up with things that are safer. Like you can't destroy your blockchain with a smart contract, whereas you can brick your blockchain if you're doing runtime development. So it's all about trade-offs and flexibility. Advantages of using Ink for smart contracts versus Solidity. So there's a few. The main one is that it's just Rust, which means you get all the benefits of Rust. So you got a mean compiler, which doesn't let you do certain things and keeps you safe, really. You also have a lot of developer tooling that's available out of the box. You've got IDE support, debugging support. You've got a whole world of third-party libraries, which you don't have in Solidity. And then you also know that Rust is supported by other people, other industries, and it's going to flourish for a long time. So I would say those are the main advantages. In EVM, we rely on a parachain publishing primitives. I'm trying to understand your question here, Socrates. So I think what you're asking about is comes back to the chain extensions. Because yeah, in Ink, you can have access to native, even though they're not native, extensions, or you can access the runtime through chain extensions, which would be much faster than running. So like, for instance, you can have a function that does one specific thing, maybe some cryptography, which is part of your runtime. You call into that from your smart contract, and that would execute potentially faster than if you'd written it in a smart contract. But isn't a contract a pallet itself? No. So a contract is run on a pallet. So it is a couple different layers. Are Inc. smart contracts supported on parachains by default? No. So one of the great things about parachains is that they get to choose, what their business logic is, and not every application needs smart contracts. If your application is hyper optimized to do one thing and one thing only, smart contracts might not fit into that model. So it is up to you as the parachain developer to decide whether or not you want to expose this functionality to users. Some chains might find it valuable, others won't. So yeah, it's up to you. Since you have WebAssembly, can you change the old smart contract with an updated smart contract? Yes, you can. And this isn't a feature of WebAssembly. Like, you can do this on Solidity as well. We do have so in Solidity, you use something like the proxy pattern, where you kind of have you've got one contract which kind of delegates to a different backend, and to upgrade, you change that pointer basically, or the address you're communicating with. We've kind of streamlined it to the point where you can just kind of, if you opt into it, you can just change the code at a certain address and upgrade your contract that way. You do need to keep in mind a lot of the same things as in when you're doing this in Solidity, which is your storage needs to look the same, or else you're going to potentially risk ruining your smart contract. But yeah, you can totally upgrade your contract if you opt into it. And then I see something about a Polkadot issue. I don't know if I can. So asynchronous backing doesn't have to do with async await functionality at all. That's more of an optimization of the parachain protocol in order to improve execution time. As for async await functionality, I don't think, it's not quite in the execution model that we've designed the contracts palette and ink with. Maybe we'll need to introduce something like this to interact with XCM, but yeah, really that's something totally different. Are there any other questions I haven't answered? Oh, okay, I do see a new one. Can you elaborate on the contract size limit? So right now that is configurable. It is as part of your Substrate runtime, one of the parameters you set is the code size limit. I think by default it's I'm trying to think. I feel like it's 64K, maybe 128K. But again, it's configurable. Although you don't want smart contracts to be too big. There's a few. So one of the things that happens is when you're executing in the context of a parachain, you actually need to pass all this code along. So bigger contracts means degraded performance. And also just from an execution point of view, you've got more instructions. It's going to take longer to execute. So you won't be able to get, your throughput isn't going to be quite as good. Yeah. Can a smart contract interact with other parachains via bridge? Yeah, it could. So you could, we can imagine a scenario where there's a pallet which knows how to interact with, or send messages over a bridge, and your smart contract using chain extensions could talk to that pallet and do something. The details here are very wishy-washy, but in theory you can. But again, it's not at the smart contract layer. This is all at the runtime. All right. Anything else? Oh, yeah, one more. Oh, no, I think that's it. All right, so yeah, if there's nothing else, and yeah, again, feel free to, to join us on Element. Go check out our Stack Overflow, ask your questions there. Go on GitHub, like try this stuff out. We spent a lot of time trying to make this easy to use and nice to work with. If you find things that aren't nice to work with, let us know. Like open issues on GitHub or open PRs. Like everything's open source, and we build it for the community. So yeah, thanks guys.